On the first problem, on the first page, guys, you really have to read the directions. So on the first problem, it says proportional. And I told you your packet, it goes in order. So when you're looking at this, it is all on this yellow or this gold paper here. It has proportional and it has rate of change for the next part to it. But proportional, it says it's what over what?
Y over X.
Y over X. So that's all I did in this first one. I did my Y over my X, Y over my X, Y over my X, Y over my X. And I simplified them. If they're not the same, it's a no, it's not proportional. So if I'm looking at this one and I'm going to do my Y over X, we skip anything with a 0 and then keep going for me, Sawyer.
Like how much you jumped or?
Nope, not how much I jumped because that's rate of change.
Alright, 9.8 over 1.
Yep.
So that would be 9.8.
You can just tell me the fractions first, okay?
9.16 over 2. 29.4 over 3. 39.2 over 4. And 49.0 over 5.
Good. So we just did Y over X, Y over X, Y over X, Y over X, Y over X. Now we simplify. 9.8 divided by 1 is anybody?
9.8.
19.6 divided by 2?
9.8.
29.4 divided by 3?
9.8.
39.2 divided by 4?
9.8.
And 49 divided by 5?
9.8.
Are they all the same?
Yes.
So is it proportional, yes or no?
Yes.
Yes, it is. You have to circle that yes, guys. That's telling me you know yes, it's proportional because all the numbers came out to be the same. Yes.
So like we don't have to do the jumps on proportional?
Proportional is just the Y over X. That's it. So it's just using the numbers in the table. Like if you look here, 3 over 1, 6 over 2, 9 over 3. Here we did 3 over 1, 5 over 2, 7 over 3. Okay? Ryder.
Say like the first two are equally on thread.
Yes, if you didn't write these out, I'm totally fine with that. If you saw the first two were not equal, that's fine. Good question. Okay? Now, the next one, Sawyer, 3 and 4, it says, does it have a constant rate of change? So now are we looking at the change?
Yeah.
Yes, and if you look, guys, I just included the exact same table. So first one, you looked at the tables to see if they were proportional. Now you're looking at the tables to see if they have a constant rate of change. And again, this is on that page here. Constant rate of change is my change in Y over change in X. I'm looking at how is it changing as I move across the numbers here. Okay? So on this one, when I looked at it, number 3, it changed by 8 and it changed by 1. 8 over 1, 8 over 1. So since they were all 8 over 1, yes, there is a constant rate of change. Please make sure you're looking up at the board for this one. It says, if yes, tell what the constant rate of change for the table is. So you actually have to tell me what it is with the labels. I got the labels from right here. $8 per hour. This was $8 every time going up. This was 1 hour every time going up. So $8 per hour. On number 9, did it change by the same way each time? On the right side. Yes or no?
Yes.
What did it change by?
9.8.
Every single time it went by 9.8. If you didn't know, guys, you could just do 0 plus 9.8 plus 9.8 plus 9.8 and see if you get those numbers. On this side, what was it changing by?
1.
Every single time?
Yes.
Plus 1 every single time. So when I do my change in Y over change in X, my change in Y was 9.8 over 1. And if you need to, write your labels in here. 9.8, and this one's kind of confusing. It's meters per second, or some people put speed. It really doesn't matter to me. And the 1 is, what are we?
Seconds.
Seconds, very good. So when you go to label it, I took, for some people earlier, 9.8 speed per second. You can write out the word, you can put a slash, doesn't really matter to me. They mean the same thing, okay? But I do want the labels on it. Any questions on the top 4 problems? Okay, at the bottom, it's asking the same thing now, it's just in a graph. The first graph, you should be able to quickly answer these. Proportional and linear. Proportional on a graph means it is a straight line through the origin. Guys, it says that right here. Proportional, straight line through 0, 0. Okay? Is this a straight line through 0, 0?
No.
No, it's not. So no, it's not proportional. Then, is this linear? What does linear mean?
Line.
Line. Guys, it's right here. Line. Okay? Is this a straight line?
No.
No. So when you do this, it says, if not, please explain why. So you should have a sentence. I have that it's not linear, and I use this right here, says it will be linear if there is a constant rate of change. It's not linear, it's not a straight line because there is no constant rate of change. I had some people earlier saying, no, it's not proportional because it's not a straight line and through 0, 0. I'm okay with either of those answers. Either way, you were explaining one of these, so I'm okay with either one. Okay. On the next one, you can use your straight edge tomorrow if you'd like to determine this. Going through all the points, is this proportional?
Yeah.
Yes, I've had people in the past be like, no, it's slightly off. I promise I'm not giving you one that close that's slightly off. Okay? It's a yes. It's a straight line through the origin. So then is it linear?
Yeah.
Yeah, it's a straight line. We just said it. Okay? I promise it's going through that line. It's going through 0, 0. And we know that, writer, because there is a constant rate of change. If you look, it goes up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2. So it would go through that point. Does that make sense? Okay, great. And if we want to know, it says, if yes, what is the constant rate of change? Well, it went up 1. Up 1 was really how much? One box is how many miles? 100 miles. And it went over 2 hours. Let's simplify that. 100 miles divided by 2 hours would be 50 miles per hour. Very good. And again, you can write the slash or the per. Any questions there? Turn the page. I was talking slow, so we're behind. This one, I had a lot of questions on the top here, guys. First of all, that entire front page is all from the first 2 papers. It's all from this yellow paper and that extra 3-1 notes. Honestly, I wouldn't touch the 3-1 notes if I were you, but some people, this makes more sense the way it's laid out than here, so I let you include them both. But otherwise, the second page is your 3-2. It kind of goes by pages almost here. So, that's my slope. Everything from this page will come from this yellow paper here. Okay? Mine is not filled out, but your R words here, that should be in this circle. What over what do you know is slope?
Rise over run.
Yeah, rise over run. And then the next one should also come from within that circle. What do you know? Rise is what? Horizontal or vertical? Vertical. Rise is going up and down, so this is vertical change. Over run is horizontal change. And again, that's written in here if you did your notes with me that day. Okay? The last part is the formula. People were stuck on the formula part of it. I have the formula on this. What is my formula? Try. Nope. That's not my formula for this. That's an equation later on.
Triangle y over triangle x.
A little bit more detailed than that.
Change it.
Change over y over change over.
A little bit more detailed than that. Guys, how do we find our change in y? How do we find that triangle y? Right here, guys, look at the board.
Subtract
Subtract what?
the second line with the first.
y2 minus y1 over x2 minus x1. Guys, this right here is your formula. That's your formula right there. Okay? So that's what you're writing down here. y2 minus y1 over x2 minus x1. And these things you're going to use throughout here. That entire page. This kind of walks you through that page. So number 7 says find the slope of the roof that ascends 6 feet for every horizontal change of 10 feet. Well, that's kind of my vertical over horizontal change. Horizontal change goes on the bottom. What did they say about the horizontal change? It's how much? 10. What did they say about the vertical change?
6.
Can we simplify that?
Yes.
Yeah. What is it? 3/5.
I thought we simplified it.
Nope. We always want to keep our slope as a fraction if we can. Okay? The next one, this is rise over run. So I looked at my 2 points and I saw my rise going up is positive and going right for my run is positive. So 5 over 2. Do we change slope into mixed numbers?
No.
No, we do not. So we leave it just like that. It cannot be simplified. 9, a lot of people struggled to find their points on this one. There were 3 points that you could have used. It didn't matter which ones you used, but all 3 of those were there. So what was my rise? Anyone?
-3.
-3 because I went down. Very good. What is my run? Anyone?
+4.
+4. Can we simplify that?
No.
And that's it. -3/4. On number 10, okay, this is my change. This is my vertical change, my rise over run. You can think of this as y2 minus y1 over x2 minus x1, or just the change in y over change in x, how we did. Again, it just kind of walks through. First one was a story problem, then it was a graph, now it's a table. The last ones will be here. It walks through that page here. So my change in y's, it went +2, +2, +2. Here it went -1, -1, -1. Be careful that you put the correct one on the top. My change in y was 2. My change in x is -1. Put them in the correct spot and simplify. Yes?
I use the restroom.
Yeah, go ahead. Don't worry about me signing. Just go. Okay. On this one, if we do change in y over change in x, -2 to 0, what's the change?
-2. It's +2.
+2. 0 to 1.
1.
+1. 1 to 3.
+2.
+2. On the top, 1 to 5.
+4.
+4. 5 to 7. +2. 7 to 11.
+4.
+4. So on my first one, it should be what over what?
4 over 2.
No, it should not.
2 over 4.
Please make sure you're putting them in the correct spot. What is my second one?
1 over 2.
What is the last one? 2 over 4 I already have. I'm not going to write it again. Do those simplify to be the same thing?
No.
Yes, they do. What is it?
1/2.
1/2 is your answer. Okay? Please don't forget I'm recording. Please don't just add in extra things to say just to say them. Thanks. All right, number 12. Remember, this is my y2 minus y1 over x2 minus x1. I told you when we did this to highlight your y's so you know what goes on the top. So we always do the second y minus the first y, and then on the bottom the second x minus the first x. On this first one, number 12, I did that, and I got a negative over a negative, and a negative divided by a negative is a positive. So I just turned it to positive 4/3. On number 13, you have to be careful because it's 6 minus, and then that first y is a negative. So don't forget to use the signs here. A lot of people just did 6 minus 5. That is not correct. It should be minus and then include that sign there. When I simplified, 11 over 1 is just 11. On number 14, what should be the top? What minus what? Good, 7 minus -8. And the bottom?
3 minus 9.
3 minus 9. 7 minus negative 8 is 15. 3 minus negative 9 is? Negative 6. If I simplify this, not change it to a mixed number, I can divide out a 3 on both the top and the bottom. 15 divided by 3 is 5. 6 divided by 3 is? 2. And I'm just going to put the negative out front. If you kept it on the bottom, that's okay with me. But I'm just going to put it out front. Any questions on that one? Flip the page. On 15, this is a varies directly. If it's varies directly, that means it's a direct variation. Direct variations means they are what? Proportional. Very good. Guys, we've gotten to the next paper here. So now we're on this. If something is a direct variation, it means it's proportional. This page and a little bit onto the next page is all this notes. Okay? So proportional. So we're doing y over x. So if I look at my graph, I picked a point and I said, okay, that point, my y value is 30, my x value is 1. So 30 over 1 is just 30. And don't forget to label them. 30, and I got them right here, inches over 1 second. So 30 inches per second. Okay? 16 is the same thing. Since it varies directly, it's a direct variation. It's proportional. So I do my y over x. Find a point on here where you can pick your numbers. Anybody, what y value did you have? If you pick a point on there. 80. Okay, so that means you picked this point. If you had 80, then what was your x? 1. 80 over 1 is just 80. So I would write 80 inches per rotation. If you said for each rotation, that's great too. Okay? You could have picked a different point. Some people wanted to pick this one. This one would have been 160 over 2. 160 over 2 still simplifies to 80. So that would have been fine. The next one is a story problem. That is like the page that I just told you we're on, the 3-3 extra practice. You have one story problem. Hopefully you have good notes on there for that one. Okay? On this, we highlight the varies directly because what comes before it is my y, what comes after it is my x. And then you do your y over x to write your equation. So like in this one, when I read it, Barney earns $27.60 in 3 hours. Assume money, that's going to be my y, varies directly with my number of hours. Hours will be my x value then. So I'm going to write y is my money over x is my hours. What amount of money in how many hours did they tell us in this problem?
$27.60 to $3.
Good, $27.60 in 3 hours. If you haven't done it yet, pick up your calculator, divide those out. What do I get? $9.20. Some people have just been writing 9.2. I'm okay with that. Okay? So then what is my equation? Like if you look on the last one, 10.25 was my k value, so it's y equals kx. So what is my equation here, Ryder?
Y equals 9.2x.
Yeah, perfect. That is my equation. The last step then is to look at, okay, they want to know for 12 hours now. Well, if you look at hours, guys, what was my hours? Was it my x or my y?
That was your
X. That's why I write this out, okay? So if it's my x, I'm plugging it in right here. 9.2 times 12 would give me how much money?
110.
$110.40. It is 110.4, but to make it money, you have to add that extra zero on, right? Okay. Any questions on that one? The one at the bottom, I'm not going to take the time to read it, but it's comparing the snowfall in Wauseon and Columbus. For Columbus, they gave you this equation, y equals 0.65x. We know that's always y equals kx. So this is my k value. So for Columbus, the rate of the snowfall was 0.65 feet per hour. You're like, how'd you get the feet per hour? Well, it says snow per hour. Okay. From here, snow for Wauseon. On this one, we have, how much did it rise?
0.50.
Oh, I didn't see you actually are still on there. I'm recording a lesson. Do you care if I call you back?
Nope, that's fine, thanks.
Okay, bye.
Bye.
All right, the rise is how much?
0.50.
0.5. And the run was 1. So 0.5 over 1 just simplifies to?
0.5.
Yeah, 0.5. So this is 0.5 feet per hour. Very good. So if we're comparing them now, who gets more snow? Columbus or Wauseon? Columbus has a higher number. Very good. Okay, go ahead and flip the page. Here, this is continuing on. It's that same 3-3, but if you look above, it was not a story problem. So guys, 20 and 21 are the same thing as 17 and 18. It's just not as a story problem. Okay? Now, I'm sorry, I don't know why it says M here. It should say K, so I apologize for that. K is y over x. So we do our y over x and simplify and write our y equals kx equation. So in this one, for k, if I do y over x, what was my y?
21.
Over what was my x?
3.
And 21 divided by 3 is?
7.
7. So if I write my equation as y equals kx and my k is 7, my equation will be
Y equals 7.
y equals 7x. Very good. Okay. Now, this part I really want you to pay attention to. On this first problem, it says plug in 30 for x. So I plugged it in for x. I multiplied the two together and got that answer. But this one says to plug in negative 14 for y. So I have to plug that into the other side. So that would be negative 14 equals 7x. How would I finish solving here?
Divide by 7.
Divide by 7 on both sides, and I end up getting
Negative 2.
-2. So -2 would be my answer. Everything else, guys, is coming from the very last part of that notes packet, that y equals mx plus b form. Okay? When it varies directly, it was still just the y equals kx. Here it's y equals mx plus b. So if you look, my m was -4, my b was 2. Remember, this is always in front of the x, this is always the constant. So on 23, what is my m? Anyone? 5/8. Yes. What is my b value? -3. Now, 24 is kind of trying to trick you here. We want it in y equals mx plus b form. Can anybody tell me what the b is? What is my constant here? 11. Now, do you notice how the mx is on the wrong side?
Yeah.
So how do I move something over? Like if I put railroad tracks, how would I move this over? Not divide. To move, you add or subtract. Since this is a positive, I would. So I'd subtract 9x on both sides. Now that this is on the other side, what is my m value?
2.
Negative 9.
-9. Where are we getting to?
I subtract.
Okay. Don't subtract anything. Okay. This is my m, or this is my m, this is my b. So don't put them together, okay? Any questions on that one?
No.
The next part, this is my m, this is my b. So y equals m x B, y equals 4x minus 2. What would this one be? Y equals
Negative 1/2
-1/2.
plus 3.
Ah, you forgot something. -1/2
X.
x plus 3. Very good. Okay. At the bottom, it's writing your equation. So when I looked, I found my slope. You could go from any points here. Okay, down to right 4 or down to down 4, right 2, or down to right 1. Either way, my slope is -2. Where was my begin here? Where was my B value? +3. My M was -2, so my equation is y equals what? -2x plus 3. Very good. On the other one, what is my begin here? 1. What is my slope? What is my rise over run? Rise is 1. Run is 5. So what would be my equation?
Y equals 1/5 x plus 1.
Very good. Nice job.